This coil spring is kind of typical of the things that you find when you're taking apart machinery or furniture in this case, and it's fairly good quality steel. This spring is 3/8 of an inch in diameter, and when I unwind this spring it'll give me a 32-inch bar, and it's great for making all the small chisels and engraving tools that I use. One of the things that I do when I straighten out a bunch of these springs is I'll leave any kind of a distinguishing feature of that spring. In this case it's that little hook at the end of the spring. I'll start by forging this bar from the other end, and that piece will be the last piece that I use. So when I see it in my scrap pile, I'll know that it's a piece of carbon steel that I can use for a tool, and I don't mistake it for something else. I just want to point out that this little round dot here on my anvil is the rare earth magnet that I'm going to be referring to later on in this video. The critical temperature for a bar is one of the first things that you need to establish when you're testing a bar that you're not familiar with. At the critical temperature, the bar will no longer be magnetic. This is not a constant, and it actually varies quite a bit, and it all has to do with how the steel is engineered to fit into the customer's manufacturing process. With this piece, it's extremely low. It's becoming non-magnetic right around at a blood red heat, which is barely visible in the shop, so I'm going to need to keep that magnet on the anvil so that I can refer back to it several times while I'm working. The next thing you need to do is figure out what the maximum hardness is for that bar, and you do that by bringing the bar up to the critical temperature and quenching it in oil. When you're testing a bar, you always quench in oil first. If quenching it in oil doesn't fully harden the bar, then you repeat the process, and this time you quench it in water. If quenching it in water doesn't harden the bar, then you have a piece of steel that you're not going to be able to reforge and retemper in the shop. It's either a piece of mild steel or it's some kind of a specialized steel that needs some sort of elaborate process for heat treating. If the quench was successful and you're working with a piece of carbon steel that's at least a medium carbon or better, the end of the bar should be glass hard right now, and a file won't be able to touch it. It'll just slide off. When you're forging carbon steel, you really don't have a lot of working time in each heat. The carbon content of the steel not only reduces its forgeability, it also reduces the temperature at which it'll burn. So you can't really heat the steel much beyond a yellow heat, and the forging range for trying to make any kind of changes to the cross section is above a full orange heat. As the bar cools down below an orange heat and gets to the critical temperature, you're really just hammer refining the surface of the metal, and that helps to refine the grain structure inside and remove any stress. And that basically just gets it ready for the next heat. And then you repeat the process. All hammering has to stop well above the critical temperature, so you'll see me constantly checking the magnet as the bar cools. And it becomes harder to judge that temperature with this sample because the critical temperature is so low. If you continue to hammer below the critical temperature, then you are going to be putting stress back into the metal. It's also important to rotate the steel around as you're hammering, and a lot more than you would with mild steel. The anvil acts as a tremendous heat sink, and if you leave one face on the anvil for too long, you could cool that below the critical temperature and again cause stress in the metal. If you're forging something really thin like a knife blade, this stress could cause it to warp or curve to one side as you're heat treating it. The final stages of forging, when you're basically just hammer refining the surface or straightening out little bends, are really done at a very low heat. Doing this light hammering just above the critical temperature helps to refine the grain structure back to its original size. Now that the rough forging is done, we can start the heat treating process.